Example 1. The inner surface of a brick is at 60 degrees Celsius and the outer surface is at 35 degrees Celsius. Calculate the rate of heat transfer per meter square of the surface area of the wall, which is 220 mm thick. Determine conductivity of the brick is 0.51 watts per meter degree Celsius. Now let's take down the parameters. What are the given data? Given data, we are giving T1 to be what? 60 degrees Celsius. We are giving T2 to be 35 degrees Celsius. We are giving X, which is the thickness, to be what? 220 mm. Okay, what else? What are we giving again? We are giving thermal conductivity to be what? 0.51 watts per meter degree Celsius. What are we asked to calculate? The heat transfer per meter cube. Alright. Let's give this question a schematic illustration. This is T1, which is the inner temperature. Is at what? 60 degrees Celsius. This is T2. Is at 35 degree what? Celsius. You are given the distance, the thickness to be what? 220 mm. What else? You are giving K to be 0.51 watts per meter degree Celsius. From here, recall the Fourier's law. From Fourier's law, we said Q is equals to what? Ka open bracket T1 minus T2 divided by what? X. Take note of this. This is minus and not positive. Okay? From Fourier's law, we have this. But the question says calculate the what rate of heat transfer per meter square. Meaning, we are to find Q with respect to what? A. From here, we want to make K the sort of Q over A the sort of the formula. Then it means we have Q over A equals to K open bracket T1 minus T2 divided by X. What are the given parameters? We are giving T1 to be 60 degrees Celsius, T2 to be 35 degrees Celsius. But we are giving X in what? Mm. So we convert from mm to meter by dividing by 1000. So we have Q over A equals to, the value of K given is what? 0.51 open bracket 60 minus 35 divided by, get X, which is the thickness in meter. What do we have? 0.22. From here, we have 0.51 times, this will give us what? 0.22. Then what is your answer? The answer is 57 point, let's confirm. 57.95. What will be the unit? The question says calculate the rate of heat flow per meter square. Meaning the rate of heat flow, because rate of heat flow is still the same thing as flux. So we are saying that Q over A, which is flux. Flux is denoted in small letter Q. Q is equals to 57.95 watts per meter square. And that's the answer. You are done.